Hello, so for this video we're going to look into the LeetCode problem 508, most frequent subtree sum. The task for this is to find the most frequent subtree sum in a binary tree. So the most frequent subtree value. So each one of these will have a value of this node, and of this node. A subtree node is the sum of all the values in a subtree rooted at each node. If the multiple sums have the same frequency, return all of them. So to understand a little bit better how this works, let's look into the class. So we're going to define a tree node. This is right here. This is one tree node. You have your value, and this is the node, the main node. And then it has a left branch and a right branch. Right? So you have the left and the right. Right now, these are to none. So in reality, if we do the diagram of these right here, that's what we have, right? A value. So this is whatever value, and this is none and none. So for this one, we have the value 5, left is 2, right is -3. So given the root of a binary tree, return the most frequent subtree. If there is a tie, return all the values with the highest frequency in that order. So we're gonna have a kind of like a dictionary or a counter. So we're gonna have a counter dictionary, which what we're gonna do here is we're gonna add the value of these, right, of this node, and we're gonna put it here. And then we're gonna do the same for this node and the same for this node and whatever other nodes there is. So to understand, this is more or less like a linked tree. So what we're gonna try to do here is all of these are none, right? So we're gonna try to change these to zeros so we can add them. And then what we need to do is we need to do a script that runs through all of the nodes in one direction and then all of the nodes in the next direction. So what we're gonna do is gonna run it through the left in transverse. We're gonna do this node, and if this node finds that there's a value of none, then it adds a value. If it doesn't, then moves to the next. So then here it finds this node, and then the next one will be this one, and it finds that it's a node. So then it's gonna change the node to 0, go back and move to the right one, find if it's a node or not. This one is none, so it's gonna change it to 0 and move up. And then it's gonna find this node. Since it changed these 2 to 0, it's gonna add. So this is gonna be, we're gonna have our dictionary, and we're gonna add, for example, if we have this linked tree, right? We're gonna add this by this by this. So this is gonna be 2 happen one time, and then it moves up, and then it moves to the right, and then it moves to the left, and it's none. So it changes to 0, and then it moves up and moves to the right, none, goes back, it changes to 0, it goes back, and then it does the addition for the next one, right? For the next node. So then it will be 0 plus 0 plus -3. So that is going to be -3, and it happened once. And then we're going to do the addition for this one, right? So 2 plus -3 plus 5. So this is going to be -1 plus 5, and that's 4. So 4 happened once, and then that's it, right? If we continue, let's say for the next one, we will go to here, to the right, goes up once, goes to the right, sees that there's none, it will add this one, and then it will add the next one, which will be this one, right? And then another one here. So that will be 2 more. So let's say we have this right here, this dictionary, right? And then we're gonna output the highest frequency. So all of these have a frequency of 1. So the highest frequency overall is 1. So your result is gonna be those 3. And then for the next one, we're gonna have our dictionary for the next example. And our code, what it's gonna do is it's gonna run through this node, and it's gonna add 0 plus 0 plus 2 is 2 equal 1. 0 plus 0 negative 5 is 1, right? And then 2 minus negative 5, you get negative 3. Negative 3 plus 5, you get another 2, right? From the addition of this whole 3, you get another 2. And that, we already have it here, so this will change it to 2. And then we check for the highest value or the highest frequency in this list of values, and we know it's 2. So then we return 2, this key. And that's what the loop should do. So we're gonna first go through all of the values and then check all of the nodes one by one and add them left, right, and the total, right? Which is the total of each one of these nodes as we move upwards. So then we need to initialize a counter. So we can do collections counter that counter. So it's gonna be empty. And then we're gonna do our definition, right? It's gonna be the subtree sum. And then this is gonna pass that node. So we're gonna pass whatever node we're passing through here. So this node right here, or any node, right? Which is kind of like a double linked list, but it's a binary tree. So in reality, if this is a binary tree, this is a leaf because this one is the end at zeros and nodes, and this is a node. This whole thing will be the node. Yeah. So then we have that, and then we need to check if it's 0, because if our little branch here is none, we need to turn it into 0, right? So as we move down in any direction. So if the node is none, this none right here, then return 0. So then we move through the iterations. So then the left node is gonna be this. The subtree sum is the node left. So what we're doing here is we're accessing the subtree and the left node of the subtree. And then for the right one, we're doing the same thing. Subtree, node, right, done. And then we want to get the total, which is gonna be the left plus the right plus the node's value, which is the main node's value. And we're gonna add this to our counter. So this total is gonna be added as a key. The number of the total is gonna be added as a key, and we're adding 1 to our dictionary count. So then we're gonna return the total so we can iterate through each one of those. So then we're gonna do, so now we have our definition, and now we're gonna populate within this, we're gonna populate our counter. So this is the logic, and now we're gonna populate the counter within this definition. So we're gonna pass the root node, through here. And now after this line we populated a counter. Then from the counter we're gonna find the max value of all of the values. So which of the values is the max and how many, right? No, just the higher value of all of the values. So the max values. And we need to return a list. So now we do a for loop for all the values in counter keys. We're gonna find that value and we're gonna check if that value is equal to the maximum value. That way we ensure, if under it's equal, then we add it to that value. And then we append them. So we append those values. So in each loop, what we're doing is we're checking for the value in this dictionary, the counter dictionary, by accessing the keys. So since we're checking the values on the list, we're checking the keys. So if the value is the same as the key, if the value in that key is the same as the maximum value, then we're gonna append it to our result, and then we're gonna return our answer or our list. So that should work for both cases. So return. Counter. And that worked. So we have both passed. And if we submit it, did okay. It didn't run so fast with some of the people, but it's there. So I hope this helps you understand how to look into these problems, and if you go through the process of all the loops and how this works, it certainly helped me. Thank you. Bye.